This is absolutely one of the coolest things I've ever been involved with in my whole career of space exploration, and that is Worldview's creation of a relatively low cost and affordable way for vast numbers of people, compared to what's been possible in the past, to get an astronaut's view, to see the Earth from the edge of space as a curved planet, this precious ecosystem, see the black sky of space, and really appreciate our planet in a way people haven't been able to in the past.
A lot of us think we know about space, but really we don't know that much about space. But planetary scientist and astronaut-to-be Alan Stern, he knows a lot about space. And so we get to talk about space and our ability coming up shortly to be able to travel to the stratosphere, to look up at the stars, look down on the Earth from a whole new perspective. We share that technology, something that I'm incredibly excited about. And also, if you have any flat earther friends, maybe just slide this podcast to them subtly and see what they have to say about it. Enjoy this podcast with Alan Stern. The truth is that we're all the master, we're all the healer, we're all the mystic.
Give it up one time for Aubrey Marcus!
Alan, great to be sitting down here with you.
This is awesome. Thank you, Aubrey.
Of course. So now a lot of kids have this idea, I'm going to be an astronaut when I grow up. And here we are with a real live astronaut. And that's like, I mean, I think probably as many people say, I'm going to be an NBA player, but actually more people get to be an NBA player potentially than even an astronaut.
That's exactly the right statistic too. It's been that hard, but it's changing. Yeah. And I think that's what's so cool about this moment in time, at the beginning of the 21st century, when it's going from rare to routine. And there's so much more access to being able to have that perspective that only astronauts have had.
Yeah. What was that first moment where you, perhaps like other kids, but perhaps a little different because you actually went out and did it, and some of this has to do with your skill set and capabilities, et cetera, but there must have been a strong moment that you can identify what people who, in the study of purpose would say, like that spark that carried through your life. Can you remember a moment or, a series of moments that led you to think like, I'm going to do this for real?
Yeah. I had more than one moment like that though, because of some reversals later, but I remember being a little boy, like in grade school, and I knew I wanted to be in sci-tech, something like that. And then I knew I wanted to be in astronomy or space. And then I was watching.
Was that just because you had a fascination with space?
Well, what could be cooler?
Right, I agree. That. Yeah.
What could be cooler, from the sci-fi to the reality, and watching, astronauts launch, it just seemed like that's an enterprise that's of 1,000-year scope. I would love to be a part of that, to contribute to that. And I can't think of a cooler job to have in that industry than to be able to actually participate in the exploration of space.
Yeah. Yeah. I remember, I think there's a fascination that a lot of kids have with that. It's this exploration of the unknown. I think that's a deep primal human drive to just see what else is out there. This explorer archetype is deep within us all.
I completely agree. And what's really unique is that only humans have it, of all the species that have ever walked on the earth. It's something really deep within us that sets us apart and also gives us a responsibility, I think, to do that well.
I've always felt like humans uniquely are positioned to be the shepherds of this planet. Like we have the ability to either create solutions or destroy. Like this is our sacred gift. And the solutions, we live in a cataclysmic planet. There's always something that's going to happen. There's going to be an ice age. There's going to be a meteor. There's going to be that. And if we can actually pull together, get our shit together collectively as one, we can potentially mitigate the damage of this next thing that is inevitably going to come. It's not like cataclysms, which have been a part of our, Earth's history since the beginning of time, are going to stop. They're not going to stop. So we got to figure this shit out. Stop bickering amongst each other. Blue or red or black or white or left or right. It doesn't fucking matter. We got to come together because there's going to be some gnarly shit that happens. And if we're not getting our shit together, we're all in trouble.
You're absolutely right. But I think it's hard in the sense that never before in the history of this species, for for all the tens of thousands of generations, have we ever been able to actually make a difference that way? We've only been global recently, and we've only had the technology to recognize that these cataclysms come all the time and that each one can be mitigated, but in different ways. So it's really only, I think, in the last 2 or 3 generations that even dawned on people that should be part of our responsibility.
Yeah. When was this? So you get this idea. What is the schooling like? When was the moment where you were like, okay, I'm on the track, I'm going to space? Like, how did that come about?
Well, the truth is I didn't do it very well because I was a slacker in high school. The classes I liked, I did really well in, and pretty much everything else I blew off.
That's pretty much everybody. So
right. And, that resulted in a bad freshman year at the University of Texas in Austin,
nice.
Of all places. Hook 'em horns.
Hook 'em.
And so I dropped out of college and got a job on a loading dock, putting tires on trucks at night, and did that for a while. Couldn't make enough money to make ends meet, so I got a second job cutting fried chickens up in Northwest Austin. And that still wasn't making enough money. And I thought to myself, you should go back and really try. You should see what would happen if you're not a slacker. And that's what turned it around for me. Because when I did go back and try, I found I had great success at it. And then I just knew it had to be within me to want to work hard because I couldn't do it effortlessly. I had to really bear down. Yeah.
So then you make it through and you get that moment. And what is the training like? What is it actually, what are they testing? What are they trying to prepare you for? Because a lot of it's got to be mental. Some of it's got to be physical. Some of it's got to be technical. What is the blend of how they prepare someone to be an astronaut?
Well, there are different ways for different purposes. Most people here in the United States that have been astronauts work for NASA, and so they go through a NASA regiment. I'm the first guy to be selected by NASA to fly as a commercial researcher, to do research on a commercial space flight, in this case, Virgin Galactic. And it's much more do-it-yourself. Virgin has a training curriculum, but it's mostly for space tourists. Familiarity with the vehicle and familiarity with the sensations. But in my career, I've done most of that stuff. I've flown in zero gravity on these zero gravity airplanes dozens of times. And I've been in centrifuges, pull 5, 6, 7 Gs, practicing for launches. I've flown on...
How many Gs does a launch get up to?
5 on Virgin Galactic, and reentry 6. And I've flown the Virgin Galactic profile. For years, I flew F-18s as a backseat astronomer. And I flew on a U-2 derivative and F-104s and other high-performance 60s through 80s era jets like you'd see on Top Gun. And so I'd done a lot of the kind of physical training that a space tourist would try to get a little sense of. In my case, I'm there to do some work. There's a very brief period of time. I've got some equipment, an astronomy experiment and a physiological experiment. So I have to know how to work them very well and to work within the confines of the cabin and the time that's allowed. And so that's the most intensive part of the training, is just making sure that you've all got that down, because the clock is ticking. There's only 4 minutes on each flight. Right now I'm lined up for 3 flights. And I want to make sure that we have a really good result, even on the first time out of the box.
So your very first flight was a Virgin Galactic flight.
It'll be in the future.
It'll be in the future.
Yeah.
So this has all been a long journey leading up to this thing. What are your feelings as you approach this moment that's been kind of in your mind's eye for a long time?
Sometimes I just think it's been a long and strange trip.
Yeah, I bet.
And other times I think I know that I'll perform well, but I think, will I be distracted by the sensations, the chance to see the beautiful Earth? I've been in zero gravity many times, so I'm used to that. But this is a brand new experience, and I'm not there to look out the window. I'm there to perform, and it'll be very obvious. So I feel there's a high bar, a personal bar, to make sure it works the first time out of the box.
Yeah, of course, it has to work.
Yeah.
That's the thing about it. Now, talk a little bit about these flights, because these flights they're pretty short. The Virgin Galactic flights.
Yeah. So if you're not familiar with a Virgin Galactic flight, they're kind of like the old X-15s in that there's a carrier aircraft. There's a big aircraft that has the spaceship slung under it. And the carrier takes it up to about 50,000 feet altitude. And once they've done all the checks, they release, and then the spacecraft fires its engines for a little over 1 minute to accelerate to the speed that it takes to go up and reach space. And it's during that period that you have all those G's, the acceleration. Yeah. And then the engine cuts off, and your weightlessness, and your, I'm sure your view out the window is just mouth-watering.
Yeah.
All right. And everything in the cabin that's not fastened down starts floating. It's just like that on the aircraft too.
Sure.
All the wires and cabling and everything associated with experiments and other gear, it's like snakes floating around in the cabin. Yeah. And so my job will be to, egress the seat, go over to where the equipment's stowed, get the equipment out, turned on, do the observations in order. Meanwhile, that's being choreographed with the spacecraft. It's making turns to look at the different astronomical objects and the Earth, and then get it all put back and stowed again before we get into that reentry. And I have to be back in my seat because you don't want to experience falling 2 meters in a 5G acceleration.
Right.
That's dangerous. And then from there on out, my job is done, and it'll be a chance to just enjoy the reentry.
And that whole thing is going to be what, 4 minutes, something like that?
4 minutes for the work period. And that's the most challenging part of it is the time pressure.
Yeah. That's you're on a tight shot clock.
Yeah, exactly. Yeah. I'll have some help. I'll have someone on the ground that's calling out the steps for me, so I don't have to be looking at a checklist, reading, checking what time it is.
Mm-hmm. What are you doing with, because I was doing a little research and saw that you were involved with the New Horizons project. Is that right? What's your role with that project, and what are you guys up to, or gals? What are you guys up to for that?
Yeah, well, this is a big project. It's been going for 20 years. It's NASA's first mission to explore Pluto and everything that's out there beyond that we didn't even know about until the 1990s. We didn't even know that part of the solar system existed. Mm-hmm. And about 2,500 people, 2,500 men and women have been involved in this. It's about $1 billion of NASA investment. And my role is to lead it since the very beginning when we were in competition with other groups that wanted to do the same mission. I've led it, and so that keeps me pretty busy.
So how did that work between, you're working with Virgin Galactic and you're working for NASA with this, or just with NASA in conjunction with this?
So I work for a private nonprofit based in San Antonio, Texas, called the Southwest Research Institute. It's about 3,000 employees, very diversified R&D company. It's been around for 70 plus years now. And we work for NASA under contract to NASA to do New Horizons. And it's not just Southwest, but also other partners like the Johns Hopkins Applied Physics Lab and quite a number of universities and other institutions. Similarly, for the Virgin Galactic flight, Southwest Research Institute is under contract to fly me on those series of flights for NASA.
Mm-hmm. And so what is the mission? What is everybody trying to hope to discover by traveling and sending this? As far as I understand, it's the farthest man-made object ever flung out into space, right?
Actually, other spacecraft have gone further, 4 of them.
Okay.
Launched in the 70s. This one, though, has made the farthest exploration of worlds. Whereas, like, for example, the Voyagers that a lot of people have heard of, they explored out to the planet Neptune.
Yeah.
Pluto's still farther out. And so by flying by Pluto, beyond Neptune, we broke that record. And now, out even further, we're studying the seeds of planets, something called planetesimals, that were the material and the objects out of which the Earth and Mars and all the other planets were formed from. And so it's really a mission into the deep
So what are we talking
archaeology of our solar system.
We're talking like giant asteroids?
Think of them like asteroids.
Yeah.
They're different in their details. But the cool thing about this part of the solar system is that because it's very far from the sun, it's extremely cold. It's almost absolute zero out there. And so everything that's formed out
what
there,
is absolute zero? That doesn't, I mean,
think of it like 400 degrees below zero-ish.
okay.
Okay. And everything that formed out there is very well preserved because of that deep freeze.
Mm-hmm.
So it's a much better, more representative look into how things were when they first formed. And so the whole mission is about two things. One, learning about these planetesimals and the seeds of planets in a way that we otherwise can't, because if you don't go out to where it's cold and well preserved, you might look at one, but it's changed over time and you're not getting a representative picture of how the seeds of the Earth and the other planets formed. But secondly, as I mentioned a little earlier, back in the 90s, we discovered this whole structure out beyond Neptune, the farthest of the giant planets. It's called the Kuiper Belt, and it's made up of a teeming number, and I'm literally talking billions of these planetesimals. And it just wasn't known before then, but also other planets like Pluto, other small planets the size of continents. And by flying by Pluto to make its first reconnaissance, we had a chance to make the first study of this whole new class of planet that we call ice dwarfs. And so from a scientist standpoint, as a planetary scientist, this is one of the most desirable missions I think anybody could be on, because by the time my generation and the next generation of planetary scientists came along, all the first missions to Mars and Venus and Jupiter and so forth out to Neptune, those had already taken place. So we kind of knew the lay of the land. And when you look back at what they learned in all those early missions, the kind of stuff like Carl Sagan would talk about, as a scientist, there's just nothing better than getting to open that box and see what a new place is like.
Right.
In the case of Pluto, it wasn't just for the sake of Pluto. It was because it was one of this whole new population of small planets. And it's like going to the first of them and learning about it, that whole class for the first time.
When you say ice dwarf, it reminds me of something that you would see north of the wall in Game of Thrones, right? Like it doesn't really, I don't have a strong astronomy background, right? But ice would imply to me water that's frozen. But is that just a name because it's so cold, or is this actually H2O in a frozen state? And what is a dwarf?
Yeah, so the dwarf planets are the smallest class of planet that we know of. And as I said, they're the size of continents instead of like the size of the Earth. Mm-hmm. They're more like the size of the Earth's moon. But they're very common in the outer solar system. And it turns out we can fingerprint their composition by studying the light from them with a technique called spectroscopy. And they're all covered in different kinds of ices. Water ice is actually the most abundant ice in the outer solar system. And Pluto's total mass is about a third water ice. But on top of that water ice is a frosting of more exotic ices that you can't have except in very cold places. One of them is frozen nitrogen. Like we're breathing nitrogen right now. It's a gas on the Earth because the temperature is warm. But way out in the outer solar system, it actually snows onto the surface and becomes another kind of frosting on top of the geology. And there's methane, which is natural gas, but it's frozen onto the surface. And there are other exotic ices there too. But what's ubiquitous about this whole population of small planets is that their surfaces are covered in these various ices, either water ice or more exotic ones.
Yeah. So these planetesimals that are comprised of this different type of ice, the idea, I guess, is that they collide into each other, and that's what ultimately forms a larger size planet, hypothetically an Earth, some trillions of years ago or whatever.
Yeah, exactly right, Aubrey. So planets build up by small objects running into other small objects and accreting together, and then something else comes in and something else, and it eventually grows to the size of a full-born planet, whether the size of Pluto or the Earth. But there's always been a problem in understanding how you get from the original dust grains, before there were any macroscopic objects, to things that were just a few kilometers or a few tens of kilometers across. And there were different theories for this, mathematical theories that work out the physics. And the computer models were kind of competing, and we couldn't tell which theory was right. There were two major competing theories. And when New Horizons made its first flyby of one of these planetesimals, called Arakoth, which is an Indian word for the sky, This was in 2019.
And this was, I saw a picture of this. It looks kind of like a snowman with two balls on it, but a little lopsided.
got it.
Like the top ball's going to fall off.
Except it won't.
It won't.
Yeah.
Yes, it won't.
Right.
Not a lot of gravity.
Not in the last 4 billion years.
Yeah.
So yeah, exactly. We call it a bilobate object. It has 2 lobes, but you described it another way. It's perfectly accurate. And when we flew by Aircoth, all of the geological signs, absolutely every one of them pointed to this newer theory of how the planetesimals formed, called the streaming instability model, that has to do with very gentle accretion, as opposed to things ramming into each other at high speed, which sort of settled the debate once and for all. It's nice to do a definitive scientific experiment, but sometimes the data is muddled and you can't really tell something's in the lead. It's more likely to have been what actually happened. In this case, it was pretty cut and dry. There were so many lines of evidence that all pointed to the same theory and not the other theory. The other theory couldn't make this thing, that now it's pretty much settled. And that's within the understanding of how planets form. That's a huge advance.
Yeah.
And it was never possible before. And now it's done. It's in the textbooks.
So you have this thing, Aircoth, and eventually, with enough accumulation of these different planetesimals fusing into it, it could become an actual planet. Like one day when Aircoth grows up, it'll be a real planet. It'll be a real boy.
Right. Exactly. Other objects that weren't named Aircoth did that and became a Pluto or a Mars or an Earth. In the case of Aircoth, maybe we should say it didn't get lucky. It didn't get to grow up.
Yet.
Right? No, but all that time has taken place. And now we know the conditions out there will never build a planet out of it.
So that time, it missed its opportunity.
It missed its opportunity, precisely. Right.
Well, sorry, Aircoth. You know, it's all good. You get to just enjoy, be present with what you are.
There you are.
Don't try to be anything more than you're not.
And it got to teach human beings something
very important.
Sacred
purpose, no matter what you are.
There you go.
You know?
Exactly.
So there's a point. So let's say, some of the planets that we know, they started in this kind of lopsided shape. How come all the planets are all round? Yeah.
Yeah, they're never anything but round, right?
Right.
You'll never see a square or triangular planet or a lumpy planet on Star Trek or anywhere else. And the reason for that is, it's actually interesting, but it takes a moment to describe.
Let's go.
So this chair is not round.
Correct.
And the reason is because its shape is controlled by the bonds between the molecules in the wood. And that those bonds are strong enough that you can make it any shape and it'll stay this way virtually forever. Okay? And that's true. And that's the reason that if you have small objects in space like asteroids that are much bigger than this chair, they're even bigger than skyscrapers, they're like the size of cities, they always look lumpy, like potatoes or something like that. They don't have enough gravity to overwhelm the strength of the chemical bonds. But as you keep piling on more mass, objects cross a boundary where the gravity overwhelms the material strength and they become spherical.
So everything just kind of compresses into itself because of the gravitational force that's created from the mass itself.
Exactly.
And is it because the mass is spinning that creates the gravitational force? No,
it's just the fact that there's mass there. In fact, the spinning works against this a little bit. So it actually also has to overcome the centripetal force from the spinning, which is just a sort of detail. But we can calculate in a computer what that size is, where objects that were lumpy, if you keep piling on mass, will transform to be spherical. And in fact, we're looking across the atlas of all of the objects that have ever been explored by spacecraft, more than 100 of them now. If you line them up by size, you see this beautiful physics take place. These lumpy things, as they get bigger and bigger sizes, they start being less lumpy and less lumpy because gravity's trying to fight that chemical bond stuff. And then it crosses a boundary and things become magically almost perfectly spherical. They might have mountains and little bumps on them.
Sure.
They might have canyons. They might even, if they're fast spinning, be a little bit egg-shaped. But by and large, this physics just perfectly works, and we see it demonstrated in our view of the solar system from spacecraft.
So arguably, the bigger the planet, then presumably the less surface anomalies like the trenches, like the Mariana Trench or the Everests, there's going to be pressure from gravity to actually homogenize those and make an even flatter planet.
Except it turns out it's more complicated. There's always some fucking detail, right?
Yeah, of course.
Right. So when you have a substantial sized planet, inside of its interior, you can get this separation that the Earth has into a metallic core. So all the iron and the heavy elements sink to the middle. And then you get this mantle, which
Wait, you mean the Earth isn't hollow and there's not giant lizard people that live down there?
No, and it's not flat either.
Dang it.
But anyway, above that liquid, that core, there is a liquid layer called a mantle, where heat is trying to escape from the deep interior, and it's molten down there. I mean, it's really hot, and that drives currents like you would have in a roving boiling pot of water. And those currents cause geological stresses up at the surface that can create interesting geology and canyons and mountains and other kinds of things that form the details on the surface, but that aren't part of the big picture.
Right.
When you see one of those beautiful pictures of the Earth as a globe made from space, you really can't see any of that surface detail until you zoom up, because that's only a little detail on the surface, like a scar. And then even on bigger planets, Jupiter is 300 times the mass of the Earth. It's just gargantuan by scale. If Jupiter's 10 feet across, the Earth is like a little soccer ball. Maybe it's even smaller. But the point is, Jupiter is this massive planet that ought to be perfectly spherical, but it generates weather patterns in its atmosphere that create its own kind of surface detail, but on a surface that's not made of rock, but that's only made of gases. So there are always these details.
Yeah. That's really interesting. So how come some of these planets form from solid matter fusing together, and some of these planets, the gaseous planets, are just an accumulation of gas? How do they form? Is there little gas planetesimals that merge together, or does all the solids liquefy into gas?
This is a really deep question, and we know the answer to it now. And the reason we know the answer is mostly because we're able to see other examples of forming solar systems far across the galaxy around other stars. And what we find is that before the planetesimals form, in every instance we found, there's gas and dust, and the dust clumps into the planetesimals, and the planetesimals build up until you get objects that are massive enough to become spherical. And guess what? Because they have strong gravity, they can now start attracting and accreting the gas. However, young stars eventually blow all the gas away. And then the gas is gone and there's no more supply of gas. So in the very young solar system, our solar system and others, when that gas was still around, the first objects to grow up to be big planets could suck up all the gas in their area. And they become these rocky metallic cores that have these gargantuan envelopes of gas around them. And so Jupiter and Saturn, and in our solar system, Uranus and Neptune, formed super early. We know that because they had to form before that gas goes away. And we can actually see around other solar systems that gas is usually always gone in only about 10 million years, which is the blink of an eye compared to 4 billion years of the history of our solar system. So the giant gas planets were the first to the finish line and got there before the gas was gone and could eat up all the gas in their areas. And the Earth and Mars came along later. They were growing more slowly for different reasons, and the gas was gone. And so they have very little gas, our thin atmosphere.
Yeah. But the planets, at some point, they're not like Jupiter's still not trying to suck Earth's oxygen into it, or is it?
Well, in a
slowly.
sense it is, but it's so far away that we don't feel that force in any practical sense.
Right.
There is Jupiter gravity here on Earth, but it's so tiny that it takes exquisite scientific instruments to measure it, and it can't suck it off the Earth's atmosphere.
Right. So we mentioned this. What are your thoughts? There's been this whole movement, and I think it largely has to do with mistrust of authority. we as people have felt like we've been misled many, many times. And because of that, we have this rampant mistrust. And then sometimes this mistrust gets a little out of hand, and you get people talking about flat Earth, right? Which is, I think, the most absurd of the mistrustful scenarios. But still, some people are out there. And obviously, we're going to get to it in a minute, but we're about to talk about worldview, which is these helium balloons that are going up, and you can actually see the curvature of the Earth. And pretty soon, it's going to be live streamed from everybody. So they're going to have a hard time explaining how everybody is getting CGI into their live streams on Instagram. Nonetheless, but you see this in a lot of things, and some of them, potentially, I haven't actually found a sufficient explanation to this question, which is, so I guess I have two questions. One, any commentary on this phenomenon, but two, specifically, if we have been to the moon, how come we haven't been back? That's the question that I find difficult to understand. And I don't think like, oh, it's faked for sure. Like, I'm not in that camp at all. But the thing that doesn't make sense to me is if we did it once, why wouldn't we want to do it again? So two questions here.
Well, the fact is we did do it. We did it 6 times. And at the time, you remember, this is the late 1960s and early 1970s. And the politics then was very toxic in this country. A lot of that was due to racial injustice. A lot of it was due to a dawning awareness that this is a planet we live on. It's very finite, and we need to take care of it. And the whole birth of that movement in the 60s was actually accelerated by the first pictures of the Earth hanging in space.
Sure.
That made it visceral for people. And there was the Vietnam War in this country. Remember, there were only 2 nations on the Earth capable of competing to go send humans to the moon: the United States and the Soviet Union. And when the United States won, the Soviet Union denied they'd ever been trying, despite the fact that now, decades later, we find their old rockets in warehouses, we find their lunar landers, everything. But they decided, we were never interested in that.
Right.
Right. And then the United States was left there on its own. And there was a pretty big political movement to make the entire military-industrial complex smaller. And even though NASA is a civilian agency, you can go just look at the NASA budget as a function of time. Around 1970, it was just cut. It was just
with the
decimated.
decline of the Cold War, the budget decreased.
And so they couldn't afford to do it anymore. And NASA wanted to. And President Nixon said, basically, NFW, nope. No more. Find yourself a more relevant reason to be. Start studying the Earth. Nixon actually said that. Invent reusable spacecraft. That was the space shuttle. Do these other things. Quit going out and collecting moon rocks. So NASA was just put out of that business. And NASA tried under the first President Bush to restart it. And they kind of had a half-hearted attempt, and it didn't work. And they tried under the second President Bush. Something similar happened. Now we're going back, but it's just been a political struggle.
So now we're going back to the moon.
We are.
When's that happening?
In the middle of this decade.
So
And that means 3 years.
Many people who've just staked a claim that we never went to the moon and we can't get to the moon for whatever reasons, or the moon isn't real. It's something from the storybook Goodnight Moon, and it's just a projection of what we are. I've heard all kinds of fantastical things. Pretty soon there's going to be a reckoning, and the reckoning is we're going to get back there again.
Right. My favorite movie about Apollo is a little indie film called In the Shadow of the Moon. And it's about how the men who were on those Apollo missions adjusted after this to be in their mid-30s and have kind of summited Everest, and what do you do next? And so it's a very interesting film, and the way it's put together with these old men that were, these vibrant, macho test pilot astronauts of the 60s and 70s. But at the very end, the question is, some people think we faked it. What do you have to say to them? And my favorite answer was from one of them who said, well, I could understand why people think we faked it because it was so fantastical for its time. And the geopolitical stakes were high, so maybe there was a motivation to fake it. But he said, if we faked it and got away with it, why would we have faked it 5 more times? Why would we take that risk?
Right.
Why don't we just declare victory at 1? And I think that's a very strong argument that it's ridiculous to think that we faked it.
I don't think a lot of people even know. And again, look, I've only just heard I tend to just leave these conversations because I find them uninteresting when people are trying to explain why planets aren't real or why we didn't go to the moon. not something that I'm worried about. I feel like we have real shit that we got to take care of. Like, why are psychedelics illegal? You know, like the things like that I tend to gravitate more towards those conversations. But ultimately, I don't think a lot of people recognize that we've been there 5 more times. You know, I think it's like everybody thinks
It's
it was
like a
just one
forgotten
time.
history.
Right. It is.
Right? Like, who else besides Columbus explored North America?
Yeah,
Right?
lots of
From
people.
Western civilization. Right?
Yeah.
And a lot of people don't know, even though you probably heard about it in school. I know I did, but it's hard to remember all but the first.
Right.
Yeah.
When I was doing a little research again, I saw that the moon, and like some other moons, it just shows one side of itself to our planet, the way that the orbits work. But Pluto's moons, apparently they're spinning in a different way.
Actually, in the case of Pluto, its largest moon, called Charon, is actually locked the same way to where only one side faces Pluto. So the reason is the rate at which it turns is exactly synchronized with its orbital period.
Right.
And that means that you only see one face.
And that's the way it is with our moon.
Yeah. And a lot of other moons that are relatively close to their parent planet, because these very well-known forces, called tidal forces, just result in that mathematical evolution of the way it spins over time. But Pluto's farther moons that don't feel Pluto's gravity as strongly, they're spinning and gyrating. They're doing kind of crazy top things. Pluto's not alone in that. A lot of the more distant moons all across the solar system are that way. But there is this difference between the farther out, smaller moons that don't get tidally locked and the closer in, bigger moons that do.
You saying tidally locked, and what makes me think is how our moon actually affects the tide of the world. And there's been a lot of theories that it not only affects the tide, it's been largely debunked, but they used to call people lunatics because they used to think during the full moon, people would go crazy, like werewolves. And so if you were acting crazy, it was like, oh, he's a lunatic, basically. He's like within the moon's tidal pull. But there's not a lot of evidence that that's a real thing, although animals do act strange, and a lot of us who are sensitive do feel a little something different on a full moon often when we're aware of it. But what is actually happening? Why is the ocean subject to the moon's tidal pull? What is going on there?
Well, it's not just the ocean. Also, the solid Earth is, but because the solid Earth is solid, there's all that strength of the chemical bonds we talked about earlier. Whereas in the ocean, because it's a liquid, it's much less strong. And so the tidal forces can actually make a bigger difference and raise tides that we see go up and down. Like my hometown in New Orleans, the tides go up and down every day. Sure. And, you know, it's different on different days because the tidal cycle, and, you know, people follow tables. And some places like the Bay of Fundy, it's just nuts how much the tides go up and down. But it's the sloshing back and forth of the Earth's oceans on a global scale, really massive, that it's hard to comprehend, that creates a friction with the solid Earth that changes the speed at which the Earth is rotating over long periods of time.
Wow.
And has a back reaction on the moon. And those two things ultimately synchronize until there's no stress anymore. There's no residual tidal forces. So it reaches a nice, happy, stable equilibrium. Just like, you know, a bowl will rest on its bottom, but it can't rest on its side. And the reason it rests on its bottom is that that's an equilibrium. And it's even impervious to, you know, some perturbations. Like if you go tap it or something, it'll just settle back. And this tidal configuration is the same thing. And that's why it happens ubiquitously, not just in planets around our solar system. We see it in planets around other stars. We even see it in binary star systems where the two stars interact in similar ways and they end up tidally locked. Yeah. So this is just basic gravitational physics writ large on the universe.
Yeah. Yeah, it's really interesting. All right, so looking beyond our solar system and starting to, you know, just posit other different star systems, et cetera, that may have life or have had life. Do you spend any time in your own, you know, thought cycles, you know, pondering, wondering, thinking about these legends of the Pleiades and the Sirius system that we find in these ancient cultures and some of these things that exist? Do you find any time in your own mind, like thinking about this from a plausible scientific standpoint?
I do. I don't think about the legends of old, although I've read about them a long time ago. But I think all of us as humans think about, is there life off the Earth? Are there civilizations? Thanks to astronomy and planetary science, we now know that the number of planets in the universe almost certainly exceeds the number of grains of sand on the Earth. It's just stunning to think about. All these different examples, and it's hard to believe that the numbers would work out that life has only arisen once or civilization has arisen once. What's really hard for me to reconcile with that is that when we look across the universe, we don't see obvious evidence of more advanced civilizations. I think it's probably because we don't know what to look for, the same way that the ants in Manhattan don't recognize the skyscrapers as not natural objects.
Right.
But there might be a different explanation. People have certainly had other ideas. But we are on a pathway to really discover this life across the universe and the civilizations too. And that's through the development of astronomy and planetary science. It's now told us the planets are ubiquitous. We've only known that really since the early 2000s. And then to find out that many of these planets are inhabitable zones where the temperature is right to have liquid water oceans, for example. So we're slowly getting the technology to inch our way forward to ultimately get to the answer and hopefully to find, other species that have also created civilizations that might be ahead of us that have solved some of our problems.
A lot of people would say and argue that these species did have a head start on us humans and have already been checking us out for a long time, and that there's a kind of global conspiracy to hide the evidence and hide the research. And obviously with new disclosure and privacy acts that have kind of come out, Freedom of Information Act, there has been a lot more strange, anomalous, unidentified flying object disclosures and encounter disclosures. It's a very interesting time that we're in now where that seems to be picking up momentum.
Well, it is. And Aubrey, I understand it in the sense that people generally know the Earth is billions of years old, and yet the human species is only millions of years old. And so it's natural to think other species might have come along a few million years before us, or maybe a billion years before us, and developed all this crazy technology and been able to do the kind of things we can't, like cross the galaxy and go visit other star systems. So it's a natural thing for people to think, but it's very hard for me to accept that a civilization that's that advanced that would come here all the way across these vast distances either wouldn't make themselves obvious because they could, and the same way that we didn't try to be stealthy about our explorations as human beings going out around our own planet, or if they wanted to be stealthy with all this ridiculous technology, why would they sort of be stealthy but not get it right?
Half-ass the job.
Yeah, I mean, that just doesn't make sense to me.
Well, from just putting on the philosopher's hat, I would posit that there are, and I have my own thoughts about, potential alien races and things. I'm not convinced that they're actually third dimensional beings anyways, because I've done a lot of psychedelic journeying for 22 years, ayahuasca, all the different plant medicines, all the different DMTs. I've definitely encountered beings, but they're not third dimensional beings. They're astral beings. And perhaps these are just projections of my own mind. And perhaps the projections of your mind are actually the same, as above, so below, as these projections externally. So it all gets very confusing to start talking about. So I'm not convinced that they actually are. But however, let's put on the hypothetical, proposition that they're actually third dimensional beings and they're actually traveling. I would suppose that as technological evolution, because even if you just look at humans, we are a kinder, more responsible, more moral people than we were at any point in history. Now, there's anomalies with that, but you look back, there's atrocities in every
But there's also, as you say, a trend that we're getting better at this.
We're getting better. It wasn't too long ago where there was the Inquisitions and slavery and all of these different crazy things that we were doing in this, manifest destiny where we just felt like it was cool to just conquer a new land, wipe everybody out.
Or some societies thought it was their their manifest destiny.
Exactly. Right. All of this crazy shit. And we're getting better. We're not there yet, but we're getting better. So imagine, all right, another 1,000 years, 10,000 years, 100,000 years. I would suppose that we're going to become even better. We're going to become even kinder. Like, we're not going to have orcas and tanks and everybody claps as they're deep in their own suffering just because they're an orca and we're a human. We're like, yeah, fuck it. They live half as long and their fins flop over and they start to go insane and they gnash their teeth against hard objects, but no big deal. Let's fucking keep the sea worlds open. Like, eventually we're going to figure that shit out and be like, no, that's fucked up too. And all of this animal torture to give us more food. Like, all right, let the animals live. I understand life needs to eat life, but let's not engage in these practices that are inhumane to all species. And I feel like we're going to get there. And I would suppose that the aliens potentially could have also gotten there. And they may just not want, they may have some code where they're like, we don't want to interfere with them too much. However, and this is to go to the other point, which is why they wouldn't want to, first of all, make themselves totally known, but why they wouldn't want to completely make themselves unknown is potentially, and this is again, just hypothesis, I'm not saying it's real, but potentially they could be wanting to just let us know that their presence is there enough to kind of keep the rails on. Not disrupt us too much, but like kind of open the possibility, like, hey, let's gradually let you know that this is a possibility. The surveys are showing that more people believe in us. People are going to freak out less. There's not going to be everybody pointing their guns up to the sky and trying to blast us. Some people still will. And then eventually, when everybody's kind of chill, they'll just show up.
That's one scenario. My preferred scenario is completely different from yours.
Yeah.
It's that whatever's being released in military reports is just a cover story for something else.
Uh-huh.
And it's whether it's our technology or it's Chinese technology or whatever, for whatever reason, the government doesn't want us to know about it. They want to keep it a secret. And so they're saying, it's not a UFO, but we can't really explain it, which creates a wonderful meme for people to be distracted from it and go talk about UFOs. Mm-hmm. That's what I tend to think. But I'm open to more data. And,
yeah, of course. I think we're all eager to kind of understand where this might lie, and potentially in our lifetimes we'll know more. Like that's the interesting thing that I think a lot of us are curious about. It's like, will there be a time, and when what would that look like for our Earth?
Well, I think they're going to be within the lifetimes of people here on the Earth now. There are going to be a series of breakthroughs where we learn of examples of specific places where we have evidence for an alien biology. Mm-hmm. And then as we study more and more, we'll perhaps learn that there are civilizations, even that they're common. And then there'll be all kinds of sociological questions. Do they have a religion? Are they good to their planets? Or did they end up being?
We should ask those questions about ourselves.
Well,
first.
Of course, and we do ask those questions about ourselves. But did they end up the Federation or did they end up the Klingons? Right? Because there's nothing in the universe, and there's no physics that forces them to become better and better like we're becoming. There could be others that make a choice that's just screw it. This is just the way we want to be. We're bad guys. We're badass. That's it. I hope that that's
possibly,
not the case.
Unless that mindset, the mindset that creates a Klingon, is a mindset that would destroy itself. Like fundamentally, that mindset will eradicate itself because it is inherently self-destructive.
It might turn out that most civilizations do that, for example, and that's why they're hard to find. Most of them have self-destructed, and maybe, hopefully, we're on the verge of escaping that.
Let's go.
Yeah, exactly. But I think that science is going to determine all those things over the next century or two.
Yeah. When you were talking about the potential for different things that were military cover-ups that just haven't been disclosed in the right way, Roswell comes to mind because I was actually talking to Ryan Hartman, who's the CEO, president of Worldview, and we're going to get to Worldview in a minute, and this is the segue. But ultimately, he was saying that these, the cover story was weather balloon, right? And people think like, weather balloon. But he was saying that there is actually far more advanced stratospheric balloons used for military purposes that were in existence at the time of Roswell. And then it's very possible that this crash site was a stratospheric balloon that was actually used for spy purposes or some other kind of tech that they did not want to disclose. And so, of course, all of the military rushes in. This is a top secret project. They're running stratospheric balloons out over fucking Soviet Union or wherever they were doing it at that point. And this was one of these tests that they were running. And hypothetically, that could be the explanation that explains Roswell.
Ryan could be completely right on this. I mean, and one of the airplanes that I flew to do research astronomy from is called the WB-57 Canberra. And back in 1960, when the United States was spying on the Soviet Union with U-2 aircraft, one of the U-2 pilots got shot down. The guy's name was Gary Powers. And the Russians threatened to seriously retaliate with weapons. Like, you're flying in our skies. You're spying on us. Mm-hmm. This is not cool. And Khrushchev gave a really nasty speech, and Eisenhower responded the same day and said, yes, that was us, but I've decided that was wrong. We will never fly another U-2 over the Soviet Union. I give you my word. He said it on national TV. So the morning after that, the Defense Department started creating the WB-57. So the president could be right, but they could still keep their spying going.
Right.
And so Ryan might be exactly right that these stories from Alamogordo back in the 1940s were all part of a cover-up, sort of like I was saying, maybe part of a cover-up with the UFO stories today of something else they don't want us to know about because of a higher purpose, a reason that they want to keep it on the lowdown.
Which also speaks to this idea that when there is this deceit, then people posit an even greater deceit.
Right, exactly.
It's like you're lying a little bit. You're lying a little bit. Well,
exactly.
What's the prevention?
I saw you cross that line.
yeah, exactly.
So you probably crossed it a lot more.
Yeah,
right?
Totally. All right, well, let's talk about stratospheric balloons, because this is the reason why we're here in Moab. And this is one of the most exciting things that is coming up on the horizon for me, and one of the most exciting things I've possibly seen. And so tell us a little bit about this project. You're the Chief Exploration Officer for Worldview. What is going on here? Let the people know. This is the first that I've talked about it. Yeah. So yeah, let everybody know what's going on.
This is absolutely one of the coolest things I've ever been involved with in my whole career of space exploration, and that is Worldview's creation of a relatively low-cost and affordable way for vast numbers of people, compared to what's been possible in the past, to get an astronaut's view, to see the Earth from the edge of space as a curved planet, this precious ecosystem, see the black sky of space, and really appreciate our planet in a way people haven't been able to in the past. And we're creating a system that's going to be safe and routine, and that whereas in the past 70 years or so, 500 people have flown to have this view, and Virgin Galactic and Blue Origin, who we love to cheer on because they're doing some amazing things too, but they're creating higher price systems that take you on very short journeys that last 10 or 15 minutes up to the edge of space and back, and with rockets and very high accelerations that require fit people and people with really deep pockets. Mm-hmm. And what we're creating is just going at it a different way. And I'm excited about it because I think the potential is so enormous. It's creating a low-cost system to do the same thing on balloons where there's no intense G-forces. It doesn't require any special physical capabilities. You don't even have to be fit. If you can get on United Airlines, you can get on a Worldview Stratocraft and fly up to the edge of space. And we're going to make it possible for thousands, if not tens of thousands of people to fly every year from bases around the world at all these tremendously inspiring locations like the Grand Canyon, the Great Barrier Reef, and the Great Wall of China, the pyramids of Giza, and so on. And
I'm
to
looking
really
forward to the Aurora Borealis one.
And that's going to be a spectacular one too.
Yeah.
I've seen the Aurora from the Arctic Circle and extensively, and to see it actually from space altitude, to be a part of it is going to have to be just so moving for people.
Yeah, absolutely. All right, so tell us how it works. These are helium balloons, and explain this process. Talk about the whole liftoff, because you guys have run over 100 test flights. I've seen the photos and all the renderings and everything that's coming from that. You're now adapting this from an exploration model into a consumer model, a tourism model. And that's what this kind of relaunch here that's happening for Worldview is so that everyday people can get up there and get access.
Right.
To this.
Well, we incorporated the company 7 years ago, and we have been flying from a wide variety of places around the United States, but mostly Arizona, where we're based, flying missions for NASA and for aerospace companies and other government agencies and for oil companies and so forth, with robotic balloons. So no people involved, mostly camera systems to study the Earth for a commercial purpose or maybe a national security purpose or tech development purpose. And we've been gaining all this experience at it by flying these lighter than air helium balloons, as you say. These are enormous structures, by the way. When they're fully inflated up at space altitudes, they measure significantly wider than a football field.
Wow,
and they're
big
gossamer.
balloon.
They're
Yeah.
gossamer. They're made of a very thin kind of polyethylene, and because they're filled with helium, which is lighter than air, they naturally ascend very gently, about the speed of an escalator. But they get up to 100,000 feet. It's relentless. They get up there in an hour and a half, and there you are. And unlike the rocket-borne, expensive ways that are being developed, which, like Virgin Galactic, I'm going to be flying on. I can't wait to do that.
Sure.
But instead of 10 or 15 minutes, a Worldview flight will offer 6, 8, 10 hours, depending upon the time of year, to really take it in, to be a part of the experience, and to go with other people, 8 passengers at a time and a flight crew of 2, a pilot and a concierge, and really spend the day on the edge of space and hopefully have a transformational experience.
Yeah, and the way that you guys are designing it, it's going to be 8 passengers, pilot, co-pilot, food, drinks, observation windows all throughout, telescopes looking up at the heavenly bodies, cameras looking down at the Earth.
And lots of communication with people on Earth.
Yeah. You can live stream the whole thing.
You could do that. Yeah. You could podcast from
I am
from
for sure
Worldcast
podcasting from,
You need
from
to.
space.
Great.
Yeah.
I'll go with you.
All right, let's go. So people understand what happens and why this balloon doesn't continue going forever. Eventually, the helium reaches a point where it is actually the same density as the stratosphere, I suppose, right?
And it just is, the balloon has mass. It's heavy. It's an enormous envelope. And even though it's very thin, it's heavy, weighs many tons. The capsule that has the 10 people aboard, the 2 crew and the 8 passengers, it weighs about 12,000 pounds. And eventually the helium just can't lift that any higher. It's reached an equilibrium with the Earth's atmosphere. And that's where it'll top out at 100,000 feet or so.
Stratosphere, technically, right?
Yeah. Not technically, actually.
Yeah.
So from those altitudes, we've taken pictures in our test flights, and for all the world, it looks like you're flying on the ISS. You see the curvature of the Earth, you see the blackness of space, the clouds and other formations are down there. They look like little scale models, right? And you don't see any borders. What you see is this one fragile planet, and Worldview is going to give unprecedented numbers of people a chance to do that at prices that are more than 10 times less than are being offered for the rocket flights up to altitudes, and for much longer periods. Instead of tens of minutes, it's something more like 10 hours.
Yeah.
So I think the value proposition is tremendous. You get a longer flight for a lot less time in a luxury cabin like you're flying on Emirates Air, and you can really understand it and communicate about it. And one of the coolest things to me is that to make the business model work, we have to do a lot of launches each day the weather's good. Just like at an airport, you don't just launch one airplane in the morning and that's it, like a NASA rocket. They're taking off every few minutes. And so if you're on a Worldview Stratocraft in 2023 or 2024, let's say out of our first site here in Arizona, you're going to be able to launch and see other balloons ascending and look across the stratosphere and see other pods with other people. You can talk to them if you want. I think it's going to be very sci-fi, really cool experience to see this and know you're part of the first wave of humans to be able to ascend and see the Earth, the cradle of humanity, the cradle of everything here, to see it as a planet which no other species could. I hope we change people's view of the planet.
I think that it cannot but do that.
And I hope we also change their view that the 21st century is really the pivot point. to a future in which space travel becomes ubiquitous, near Earth as we're pioneering, and farther away as well. We're part of that progression.
Yeah.
That's our intent.
Do you think that because there's, many of the astronauts, I think the statistic is over 80%, have a phenomenon called the overview effect, which is a deeply profound spiritual experience of seeing the Earth without borders, seeing the Earth as one home, and all of the divisions of race and religion and creed and on nation and all of these different things it just evaporates when you see from that unique perspective. Do you think that this is going to, create that type of perspective shift for people?
I think it is. Back in July, when Richard Branson flew on the Virgin Galactic space line that he developed and paid for, more or less, a friend and colleague of mine, Sarisha Bandla, was another one of the crew members. And right after she got back, I spoke to her a couple days later. This is an engineer who's a vice president at Virgin Galactic now. She went to Purdue and then went into the commercial space industry. And then she was lucky enough to get selected to be on that first flight. I asked her what was the most impressive thing that she saw when she looked out the window. And she said, it was that it was overwhelming. It was so emotional for her. And so, if you can experience that so viscerally, what would it be like to hover over a place on the Earth for 6 or 10 hours?
Yeah, because in the other one, you got adrenaline pumping like hell. You're just recovering from
you're
massive
distracted by all these sensations.
All of these things are happening. You got 4 minutes. You got a technician like yourself flying out of his seat, handling some shit that's going on. It's a lot to take in 4 minutes rather than 8 hours.
And, even talking to professional NASA astronauts, they pointed out that for them, they're flying at 18,000 miles an hour. You cross the continent of North America in 4 or 5 minutes. And so the terrain is always changing, and you never can really stay and contemplate a place because you go around the Earth in 90 minutes, and the next pass, the Earth is turned, so you're seeing other parts of the Earth. And the worldview experience is going to allow people to sit over one of these wonders of the Earth like the Grand Canyon or the Aurora and be immersed in it all day long while the lighting is changing, maybe the weather down on the lower atmosphere is changing, and really hover over the Earth from a space-type altitude. Have a kind of view no one's ever had, no human being has ever really had before. No one's ever had this experience of being able to see the changing planet below them. Not to move from place to place, but to be over a place, particularly a special place.
Right.
And to watch it go through its day from the space altitude. I think it's going to be transformational.
Wow. I can't wait. I absolutely can't
I also
wait.
think I can't describe it till I see it.
Of course.
I'm imagining, and I think it's a pretty good, educated, scientific guess, but I'm sure it's going to be better than I can imagine.
I believe it too. So tell people, a lot of people hearing this, explain to people how this works from a safety perspective, how you go up, how you come down, the safety measures that are put in place, because I think that's going to be people's number one concern. All right, it sounds amazing. Obviously, finances are a concern. But again, this is 10 times more affordable than any of these other projections of eventually what it's going to cost. So we're talking, I don't know, somewhere sub $50,000. Is generally what's looking. But obviously, a lot of things have to happen. Well, nonetheless, it's an unbelievable experience that people get to have. But I think the reticence that a lot of people are going to have is like, well, fuck, like this sounds dangerous. But it's in talking with both yourself and talking with Ryan Hartman, the safety of this seems really impeccable.
That's what we intend for it to be. And let me start by saying, you mentioned that we've flown over 100 stratospheric balloon missions in the history of the company. We've never once had a crash. We've never once had an accident that would have killed people. We have had a couple of instances where maybe we had a balloon mission that we meant to go for 30 days, and after a couple of days, we had to bring it down early. But we've never flown a mission up to the stratosphere and had a problem. So we have a really good track record. And I want to compare that track record to Virgin and Blue Origin, who have also had spectacular track records. But right now, I think Blue Origin has flown 16 or 17 flights. And Virgin has flown 6 or 8 to space altitudes, and we've got 100. under our belt.
And unfortunately, there was some tragedy on some of the flights.
In some test flights for the other companies.
Yeah.
Right. And so safety is our hallmark. On board, the systems have backups. They're redundant, so that we know that if the radios go out, the pilots still have a second way to talk to the Earth. If the air conditioner goes out, there's a second air conditioner on board. Rising on a balloon is kind of a foolproof ascent system compared to the number of things that can go wrong with a rocket engine, for example, or even a jet engine. But once we're up there, it's very simple to come back down. We just start letting the helium out, and we start a gentle descent. And when we get down low enough, we detach from the balloon and fly down on a parasail to a prepared landing site. And then at the moment of contact with the Earth, airbags go off, and the collision is just a mile or two per hour. So it's more gentle than landing on a commercial jetliner. And even that system has a backup because we carry a parachute in case the parafoil fails. So it's all meant to be as simple as possible and as redundant as possible to guarantee that we're not going to have accidents. People aren't going to get hurt. And of course, the success of our business depends upon being very safe.
Yeah. When I was talking to Ryan, he was saying how it's not a pressurized balloon system where that actually there's giant vents that you have on there anyways that you open up, these big flaps to start letting the helium out anyway. So even if something crashed into the balloon and put a big hole in it, that would just mean you start your slow descent a little sooner than normal.
That's right. That's absolutely right. And by the way, that tourist balloon system is also going to get used for scientific research. I think there's going to be a lot of media and marketing that's going to take place when people like yourself and others have access to being able to do this. We think there are going to be corporate promotions and ad campaigns and things that are done. We want to see the widest number of use cases for this new technology to give access to the high stratosphere.
Yeah. So just to summarize how it goes, you have a zero pressure helium that's not flammable,
right? Exactly.
Non-flammable gas, and it's going to rise up, and you're going to slowly let out helium. And actually, I heard as well, and correct me if I'm wrong, but the helium is actually healing to the Earth's ozone layer. Like it's beneficial to release the helium up to the ozone.
Well, all of the helium that is produced ultimately comes from processes within the Earth. Mm-hmm. For example, radioactive decay of rocks deep inside the Earth, and when letting that back out, we're giving it back to the Earth in effect.
Yeah. So you start letting out the gas, and it's going back. So zero environmental impact of letting out the gas at that point. The balloon starts to descend when you're ready for it to descend. And you can actually track the flight based on reliable trade winds that are up in the stratosphere. It starts to go down. At a certain point, you open up the parasail, which is like a parachute, but it's going to allow a little bit more mobility to actually travel and hit your kind of landing approach.
Exactly.
And if that fails for whatever reason, and then a gentle airbag landing on the bottom, and if for whatever reason that doesn't work, then there's a parachute system, which is the same thing that all of these shuttles that end up landing, they use parachute systems, right? Isn't that how most shuttles get back down to Earth?
Yeah. And if you think about it, when you fly in a commercial airliner or even a private jet, they don't have a parachute backup system. We're taking that extra step to make sure that if we have to go to plan C, we're still not out of luck, and then everybody's going to be safe.
Yeah. So, I mean, this seems like it's obviously with anything, there's risk with anything. There's risk in flying in a commercial jet. There's risk in getting in your car. Probably one of the most risky things is actually getting in your car. That's what statistically is shown. But in any time you're doing one of these things, but it seems like in this case, it's a very, very reasonable triple redundant system that's designed to make this as safe as possible to give the maximum effect with the minimum risk.
Yeah, and I wouldn't be flying on some of the test flights unless I thought it was personally safe. I plan to fly a lot for a number of different reasons, including to do research. And I'm going to make sure, from my perspective, that we build the safest possible system and learn to replicate it over and over and do it day in and day out in a way that you never think twice about the safety. Inside the company, we will, but our customers never should have to.
Yeah. Epic. So people who are fired up and are like, look, I got to do this. And I can tell you, you know, from my standpoint, I am incredibly eager to not only take the flight, but also do some incredible things while I'm up there. I want to take my wife, Vailana, up there and some other musicians and be looking down at the earth and let her offer, she's a sound healer, let her offer a sound healing to the planet, you know, from space, and all of these amazing ideas that are coming across. Like you said, podcasts in space or concerts,
Exactly.
whatever you want to do.
Yeah.
There's so many different cool things that can be
All
experienced.
kinds of
And
art,
the whole
for
thing
example.
is going to be like a real ceremony, you know, and it's the whole process is going to be a beautiful thing to experience. But for people who are fired up, like I am, about this, and what is the, you know, how does someone get in line? Is there going to be pre-sale offers? Is there going to be, you know, what is the way to start to prepare to book your experience?
Well, we've announced that we're in this enterprise now, and that we've started the process for the Federal Aviation Administration to certify these vehicles as safe. We have a website. Just look up Worldview, go to our website, and sign up there. You have to put down an earnest money deposit so that we know you're serious. But that's going to be a very small amount of money, $500 or $1,000. And then you're on our list and you're in line. And then as we develop the vehicles and get them into test flight and so forth, and we look further downstream next year, we'll come back and say, now, are you serious? Would you like to finance this flight like you'd finance a car? Or do you want to just write a check? I think a lot more people will want to finance it, because who writes a check for a car? Very few people.
Mm-hmm.
And that's when we convert you over to actually getting in a flight manifest.
And choosing your launch port and different things depending on how those roll out over the years.
And you know, you're just saying about bringing the whole group with you. This is an interesting metric, but for the cost of one ticket for one person to go on Virgin Galactic, you could rent an entire flight for 8 people and take your family or your colleagues, your best friends, your band, whoever, for the same price. You can rent out the whole vehicle and charter a flight.
Yeah. Unreal. Well, it's been, you know, one of the things that I've been most excited to be involved in. I was very fortunate to get access to actually invest and be a part of this company. And I'm just excited to be able to offer this perspective to myself, of course, first, and everybody else who's going to have access to this, you know, world-changing perspective, truly, where we get to hopefully get that critical mass of people who stop seeing things in this myopic view of, you know, my this, my that, my this, my that, and get to the place of, oh, this is our home, and these are our resources, and this is our mother.
And I believe in this too, like you do. I'm not just an executive in the company, but also one of the investors. And what I'm looking forward to maybe most, besides flying and seeing the experience myself, is seeing what creative humans do with this. You know, in the same way that no one had any clue when the first PCs were coming available in stores. No one knew how tremendously they would change our lives. And the same for airplanes, and same for drones, and so many other things in life. It's the creativity of what we haven't thought of that people will be creating in the 20s here. And I said this at the outset, I really think this is going to be very special, because this is the one moment when it's new. And it's not just for select astronauts, but it's also not the 2030s or 40s or mid-century, when this is pretty commonplace. The way that airplanes were new a century ago, and everyone who took off in an airplane was like just blown away by the experience of seeing clouds from the other side, you know, and to see the lay of the land and the way cities and geography works, you know, and coastlines. People will look back on the first 10,000 people who fly with Worldview and say that was a really special time in the early 20s when it was all new and everyone was figuring out what the applications were and figuring out how transformative it was. And it wasn't old hat the way it became by the 2040s. So I'm really looking forward to that kind of specialness to this time as we start to fly year after next.
Amazing. Well, we'll have to have this conversation again as this evolves, as you get up in the rockets, as you get up in the balloons, and hopefully as I get up in the balloons shortly thereafter. So
absolutely, Aubrey.
Yeah. Thanks for coming on. It's great to have this conversation, and thanks everybody for tuning in. Much love.
To climb aboard the first spacecraft powered by the winds of change. To lift off from the world's wonders and gaze in wonder at the world. To linger with the stars and touch down feeling more in touch with our planet than ever. That is your mission.
Thanks for tuning into this video. Make sure you hit subscribe. Follow me at Aubrey Marcus. Check out the Aubrey Marcus podcast, available everywhere. And leave a comment. Let me know if this video resonated or what else you would like to hear from me in the future. Thank you so much.